And a big g'day to everybody up there at Wedderburn. It's Graham Anderson here from Agriculture Victoria with a bit of an update on what's going on with our weather patterns and what's normal, what isn't, and what's next. We have a few products with Agriculture Victoria. Some of you might have seen the Break newsletter, which comes out monthly, or there's Deep Soil Moisture Probe monitoring, which is looking at how much rain is in the bank in our soils around there. But I'll give you some information about where to get hold of those if you're interested. Okay, this is where it rained in Australia last year. So this is deciles, and this sort of blue colour here is where the rainfall last year was in the equivalent to the wettest 10% of records in the long-term record, and this is where it was in the driest 10% of years. But you can see most of Australia was pretty wet, and Victoria had a fantastic winter and spring, all thanks to a thing up here called the Indian Ocean Dipole, and we'll talk about that in a minute. So a big part of variability. But you'll notice this is all of the rainfall records for Victoria going back for the last 116 years, and you can see back 1900 there, and that's the long-term average for Victoria. And you can see last year's rain was wetter than average, which is fantastic, but there's been a bit of a while between drinks, and you can see there in the last 20 years we've really only had 4 years where Victoria's had more than its long-term average. So we'll talk a little bit about what's going on. We're still going to have plenty of variability in future, but also puts a bit of pressure on our water planning. So here's a great long-term rainfall record for Wedderburn. This goes back to 1883 and all the way through to last year's rainfall. And you can see this line through the middle is basically the long-term average in millimetres, which is 469 millimetres. You can see some years it's up to almost 800 mils, and some years it barely can get to 200 mils. So a lot of variability in the record. It was great to see last year above the line, wetter than average. But if we look at the last 20, there's only been 5 of those years above the long-term average, and 15 have been drier. So that certainly put a fair bit of pressure on our water conservation efforts. And so we'll talk about what's behind that variability, but also why perhaps some of this drier run of years has been happening. Okay, so here we've got that Wedderburn rainfall record, but this is the summer rainfall record back to 1883, autumn, winter and spring, and you can see there a lot of variability. That was a really wet summer. We had a lot of rain there in that 2010, but doesn't happen very often. But what you can probably notice is that autumn's been the year. The lack of wet autumns in the last 20 years has certainly been part of that dry pattern, and as to the lack of sort of wet winters, there's been a few there, but certainly a lot more drier, and that's one of the things that's really leads to that a lot less runoff coming off our farms. So where does that all variability come from? Well, to make rainfall, in this part of Victoria, we need two things. We need a good source of moisture, and that moisture, most of that comes from the really warm tropical oceans, and that feeds in. But also the reliable rainfall down here is because of where the moisture hits the cold air that's circulating down around the Southern Ocean here. So where these cold fronts and cold air hits that incoming source of moisture, then the rain drops out. So that's part of our reliable rainfall. And we've got the El Nino Southern Oscillation, really key driver of variability. Some years in La Nina years there's lots more moisture and cloud blowing in, which feeds into our weather patterns down here, and in El Nino years it's the opposite. There's a lot less cloud and all the moisture's out in the Central Pacific. Last year we had the Indian Ocean Dipole. It had lots of warm water up here feeding in heaps of moisture, which was really welcome for our winter and spring, and so that's really good. But some years you can also be in its dry phase as well. So that's what seasonal variability is all about, the supply of moisture from those. The other thing is the triggers, which is really this cold air down south. You can see all the cold fronts there that whiz around the Southern Ocean. One of the things that's sort of probably a bit different is that 25 years ago, if a farmer saw a cold front off the coast of Perth, you'd sort of think we had 3 days and we'd have rain here in Victoria. Well, these days we sort of tend to watch those fronts slip south a lot more often, and that's because these winds down here in the Southern Ocean have shifted further south. So that's part of what's behind our sort of drier signal these days, and they're expecting that to continue. The other thing with seasonal forecasting, a lot of the seasonal forecasters look at sea surface temperatures. So along the equator here, the water's a lot warmer than it is down here, but this is an anomaly map, and so these colours are where areas of ocean is warmer than it is normally, and these colours blue where it's cooler than it is normally. So here's an example of spring 2006. We've got all this cool water to the north of Australia, and this is an El Nino here, so that really warm water there, lots of cloud happening, but what that does is it tends to drag a lot of the moisture and rainfall back out this way, and there's not a lot of moisture coming out of this sort of drier area here. So that's what a dry pattern looks like and what seasonal forecasting is, and that's what's behind our bigger dry years and droughts when we get that sort of a pattern, and a lot less cloud when this is happening. If you keep an eye on this little area here, we'll just have a look at how that area of ocean looks when we go to, say, a wet spring of 2010. So hopefully you've noticed a bit of a difference there. You can see the big La Nina here in 2010, cool water there, but all the warm water now is over our part of the world. That would have generated heaps of cloud, heaps of moisture to feed into our weather patterns, and then it's just a matter of, actually individual rain events as to whose farm gets it. So that's what's sort of behind seasonal forecasting, and a big driver of our variability. And this one's just showing what happened last year, October 2006. You can see really warm water up here to the north, really warm water off Sumatra, and that was great for generating lots of extra cloud, which fed into all of our weather patterns. So that's what's behind good old-fashioned variability. And when we look at that Wedderburn record, and we look at since 1883, and there's been 32 El Nino years in that record, and when we look at them and see what's happened in the August, October, so in that spring, which is a high runoff sort of time of the year. Normally, longer term, there should be a third of the years that are in the red, which is decile 1 to 3, and a 30 years are average, which is yellow, and a 30 years are wet, decile 8 to 10. But when we look at those 32 El Nino years at Wedderburn, two-thirds of them were in the dry range, decile 1 to 3. So you can see that the El Nino years really increase the chance of a dry year. But it is occasional one can be wet, but it really does increase chance of dry. In La Nina years, when there's a lot more moisture in Eastern Australia, you can see that the chance of a decile 1 to 3 spring is reduced. It can still happen, but certainly the odds are more in our favour for average or wetter. So that's a big part of variability. And in your part of the world, we've also got the Indian Ocean dipole. So when it's in its drier phase, this is where it's drier in parts of Australia, and you can see in that record at Wedderburn that whenever the Indian Ocean dipole's been in its drier phase, it doubles the chance of a dry spring as well. And when it's in its wetter phase, like last year, quite a strong driver for wetter years down here, and a strong influence at Wedderburn when we get the Indian Ocean dipole in its negative phase and it's firing up with water, that 70% of those have been decile 8 to 10 at Wedderburn, and so that was really good last year, but they don't come every year, so that's all part of the variability story. Now, one of the things is there anything different now that's not just variability? Now, one of the things, if you reduce rainfall by 10% over a number of years, then you can actually have a much greater impact on catchment and runoff. So this is runoff from the 70s at Bet Creek. It's stream flow gauge there, and you can see the sort of runoff that was happening down the creek there really since sort of 1996. Apart from that wet year in 2010. Runoff's fallen off a bit of a cliff there, and so that's part of the issue in terms of managing water storage. Is we'll still have years where it'll be wet and there'll be water around, but it's just the distance, the gap between when we get good flow events. And this is modelled from rainfall for Bet Creek, but you can really see this is the long-term average for the last 100 years, and a lot of variability there, but it was always flowing. But again, up until about 96, you can see water flow has really dropped off, and that's largely representative of a lot of catchments in Western Victoria, where the runner of dry years, it's also accumulated with groundwater systems sort of dropping a bit, so that base flow is not there. And so we'll still get runoff, but our key challenge is how do we plan for these bigger gaps between runoff events. And here's the temperature trends for Victoria for the last 100 years, maximum temperature trends, so that's summer, autumn, winter and spring, and you basically you can see the last decade's been getting warmer. The Bureau described basically climate change as we're squeezing in an extra month of summer, so the summer season gets bigger. The winter and the growing season gets a bit smaller. Winter a bit milder, so I think a lot of farmers observe that's probably good for plant growth and everything. But one thing, if we look at with spring over the last 10 years, most of the springs have been between 1 and 3 degrees warmer, which is really summer arriving earlier. You can see last year was just under average, and that's fantastic when we get a decent cool spring, but we're getting more of these. And I guess one of the things is with the bigger summer season, it just puts more evaporative demand on our plants and pastures, and also just adds more pressure on our water storage. And what's the culprit? Well, basically, as things have been getting warmer, basically the pressure pattern over this part of southern Australia has been getting stronger, and that's what we've observed in the past. And you can see here, this is pressure over southern Australia since 1950. It varies a lot from year to year, and in these sort of high pressure years are typically El Nino years, and that's that 2015 high pressure year. But you can see there's a trend there, and that's exactly as what they expect to happen, and it has happened. So that trend is very likely to continue. And you can see here, this sort of is the region of Australia which has got an increasing pressure since the 1950s. So that's part of what, that just squeezes out a few rainfall events every year, and part of why we'll still have plenty of variability in future, but we've just got to be planning for dealing with dry periods more often. While we talk about daytime temperatures getting warmer, one of the things is when we have clear skies and those sort of dry years, we're still got plenty of frost risk around, because at nights it can still get quite cold. So daytime temperatures are going up, but we've still, for the time being, still got frost risk, which really comes with some of those dry years when we have a lot less cloud cover. Okay, and what about the future? Future projections? Well, climate change models, when the scientists enter the world gets warmer into their climate models, and what a lot of the models sort of suggest is that they think that it might get wetter up the top end, so as the tropics expands further from the equator. But one of the things that the models tend to consistently think that it'll get drier down south, and that's largely because of that rising pressure pattern that we've already seen started to happen. And this is interesting. This is actually since 1997 what's actually happened with rainfall in April to October, which is traditionally a good runoff years or time of the year. So what the sort of climate models have been expecting longer term have been what we got. So we'll still keep getting variability, but it's just that the odds of drier more often is likely to hang around for a bit. Now, there's a bit of work done here by David Stevens, which was looking at the seasonality of rainfall, so summer dominant rainfall zones, uniform throughout the year, or winter dominant, and how they might be changing since 2000, and compared them to the previous 100 years. And basically all of those climate zones have been shifting south, and that's what's been happening, and probably what we expect to continue. So one of the things or messages from that is that the successful farming happening all throughout Australia in climate zones. It's just dealing with the change that's a bit of the challenge. So when we look at dealing with water storage down south, we've always had pretty reliable and regular runoff periods. As you head further north, those runoff periods, they still happen, but they're a lot less reliable. So there's deeper dams and a lot more done on water reticulation to keep stable water supplies up. So that's part of the challenge, which I guess was what you're dealing with up there. So now there's lots of things on our side in terms of what we've got to deal with increasing climate variability and climate change. Got lots of modern technologies, RD, genetics and innovations, which are all helping farming get better. Really key one though, improve farm and regional infrastructure, especially when it comes to storage of water and fodder for our part of the world. So it's really about how if we're having bigger gaps between runoff events and good water flows, then how do we find better ways of storing water and holding it over, and less of it evaporating off. So that's really important stuff. Lots of good things too. We've got growth in local and export markets. Getting better at business management for variable years and incomes are a really key part of farming these days, and also farm planning and really looking after our soils and pasture cover during those sort of dry years, so that we're ready to bounce back for when it rains, because it always will keep raining. It's just really about how we better cope with some of those dry phases, and surrounding yourself with good networks of information and support so that we can make the most of our farming future. So I hope that's been of use. Good luck with your water planning workshop today. If you want to get hold of the break or soil moisture products, just drop an email to this address. All the best.